8.4. And what do I need to do if I don't have a paper to take notes? Good thing. Just see it and only try to do the last three numbers. See you tomorrow in class.
Section 8.4, which is multiplying and dividing rational equations. Now, we're going to give you some simple examples, and the first one is if you had A times C divided by B times C, what do they have in common, both top and bottom? Well, it's the C, so then you would eliminate those, and your answer would just be A over B. Now, one with numbers, 15 divided by 45. 15 comes from 3 times 5, and 45, it's 9 times 5, but that 9 breaks down into 3 times 3 times 5. Since we have a 3 in common, we could eliminate that, and of course you could eliminate your 5s. Anytime that you're left over with nothing on top, you need to make sure you put a 1 over 3. Now, let's see one with numbers and variables. Let's say you had 20x over 5. Well, 20 is the same thing as 4 times 5, x over 5. The 5 is what we have in common, so we just put this over 4x. Now into problems that are a little bit more complicated. So in this example, we're starting to get back to some quadratic functions, the way we used to have before. We're going to have to factor out. So you could either do the table with the factors and sum if you need to. You don't have to. Now factors for 15 are 1 and 15, 3 and 5. Because it's negative 15, you know they have to be different signs. We look at the negative 2. Since it's a negative, that means your larger numbers should be negatives. Now 1 and negative 15 is a negative 14, and then we're looking for the negative 2. And of course, that would be the bottom one, which tells me it should be x plus 3 and x minus 5. Now, when we look at the denominator, which is x squared minus 9, you could do the table also, but not necessarily. Because you should remember, hey, you could take the square root of 9. When it's a number that you could take the square root of, remember it has to be the same number, one positive, one negative. But in case you need to see the table, it's right there on the right side. Negative 3 and positive 3 are the only ones that give you the 0 that we have in the middle. We look at both denominator and numerator, and what they have in common is x plus 3. So of course you eliminate those, and my answer would be whatever is left over. So there's the answer again, because I went a little quick. It's just whatever you have left over, that's what you leave. In the next example, it gets a little bit more challenging, but it's not difficult, because now we actually have two fractions that are being multiplied together. So we look at this, and we're like, taking the first one, what did 3x minus 3x squared have in common? Well, they both have a 3 and the x. So should we be able to factor that out? Yes. We factor out a 3x. What's left over? 1 minus x. Now, so you could see that it is something that works. Please go back and multiply. Is 3x times 1 going to give me a 3x? Is 3x minus times the negative x going to give me 3x squared? And it should give it to you. Now, to eliminate the bottom, I'm not going to make the table because there's no room. What two numbers multiply to 5? The only two are 1 and 5. Now, because it's a negative, one has to be positive and one has to be negative. The question is, the middle number is positive, so that means your larger number should be positive. And then when you look at x squared plus x minus 20, when you think about 20, you're either looking at 1 and 20, 2 and 10, and 4 and 5. Because it's a negative 20, different signs. When you have different signs of numbers, you end up subtracting. So what two numbers are going to subtract to become a positive 1? The only ones that work would be 4 and 5. Now, one has to be a positive, one a negative, like we said. Since the x is positive, that means your 5 should be positive and your x should be negative. When we look at the denominator, 3x, you can't factor anything out, so that one just stays. So when you start looking here, can you eliminate anything? There's actually two things. 3x and that x plus 5. Now, this that we have left over up here looks a little bit weird. Let me turn it around, and it's actually negative x plus 1. Now, this negative x plus 1 that I just wrote, and the one in your denominator here, we should somehow possibly be able to eliminate it. Now, if I factor out a negative 1 from this up here, that negative 1, you factor it from x, it becomes a positive x. If you divide a positive 1 by a negative 1, then that gives you a negative 1. We still have that x minus 4 on top, and of course the x minus 1. But with that elimination that we did, or factor out of that negative 1, we should be able to cancel those two. What do you have left over? Negative 1 times x, which is a negative x, and negative 1 times a positive 4, which is a negative 1 times a negative 4, which gives you the positive 4. Next example, it's pretty simple. It's actually easier than the ones before because you're just getting numbers without pluses or minus. Nothing that needs to be factored out. So this is the problem. You combine whatever you can. Remember, when you multiply, you add your exponent. So this becomes x to the 6, y to the 6. The bottom, I'm multiplying 2 and 6. You always try to kind of manipulate the problem to where it looks like you could eliminate something either in your denominator or numerator, or actually in both. So this x stays by itself, and then y to the 4th. So you have a 12 on top, 12 on the bottom. They eliminate. Your variables, remember when you divide, you actually subtract them. So I have 5, 6 minus 1 is x to the 5th. And then y6 minus y4 is actually y to the 2nd. Now this last example, it is pretty simple. It's just like the previous ones, except it's a division one. Now when you divide, you need to keep in mind you actually need to flip the second fraction. I don't know if you guys remember this from elementary or middle school actually, but you do need to flip the second. So we're going to go by parts first. Looking at the 7x, there's nothing I could do, so I'm just going to rewrite it. When I look at the bottom, 2x minus 10, well, I should look at it and notice that both 10 and 2 are even numbers, so I should be able to factor out a 2. So that gives me that part right there. When you factor out a 2, it just says x minus 5 inside. Now, because I'm supposed to flip my second fraction, I'm going to start working with the bottom part. Two numbers that multiply to 30, but add up to a negative 11. Well, at this point, I know it has to be 6 and 5. 6 and 5 multiplies to 30. Now, it's a positive 30, so they both need to be the same sign. Because it is a negative 11 in the middle, I should know both are negatives. So I should have minus 5 and x minus 6. When you look at the top, it is x squared minus 6x. The only thing they have in common is an x. If I factor out an x from x squared, I have x left over. And if I factor out an x from 6x, I just have 6 left over. So once at this point, you should start eliminating. X minus 5, x minus 6 goes away. So really the only thing I have left over is 7x and that 2 and x in the bottom. But these x's, we should somehow end up eliminating those. So my answer would be 7 over 2. That's it. So that complicated problem just ended up being a simple fraction. Now, I would like for you guys just to take some white sheet of paper and actually try these 3 problems. Go back and look at the video and actually try them and see how bad or how easy they are. They're not that difficult. So here are the 3 problems. It's one of each kind. It's a regular one where there's multiplication, and then a division one that turns into a multiplication one when you flip the second one over. Try to bring these 3 problems back to class tomorrow finished, worked out, and have questions. Don't overthink this. It's just factoring. If you can't eliminate, then try to factor. At least give them an attempt, please. Thank you.